AWS Lambda Layers to help us manage our machine learning powered application. So in our company, we have a serverless setup, and we make the most out of AWS Lambda along with other services like AppSync, even the parameter store, and all the other things that are used to along with the serverless mindset. So to start off with, I am Joshua Arvin. I am the Chief Technology Officer of Complete Business Online, Insights, and Jepto. So I am also one of the subject matter experts of AWS. And along with that, I'll also share some of the things that I've learned in our company, especially on the machine learning part as well. So let's start with concepts and what is the problem that we're trying to solve. So basically, the goal of this talk is to help everyone make the most of the tools that they use. Sometimes, when we use these tools, we have the tendency to just check the hello world examples and then get it to work, and then you consider it as something that's enough to help you build your production applications. But once you start to work with teams, the challenge there is you'll start realizing that your project's getting bigger, and there are cases where the number of Lambda functions that you'll use increase significantly as your projects gets more complex. So in this example, we have a step functions. So this is just my representation. And in our step functions, we use R inside Lambda, and we also use Python inside Lambda. So you can technically use Node.js and other languages, but this is one of the advantages of doing something serverless, using the function as a services along with the ability to reduce the cost significantly using the serverless mindset and concepts and tools. For machine learning, so take a look at the screen. So basically, machine learning has helped us a lot for the past couple of years to automate a lot of things, automate decision making, and being able to do something to help humans, especially let's say that I want to, for simplicity reasons, let's have an example where I get to classify if this is a dog or a cat. Or maybe I get to predict the future using like forecasting algorithms. So with machine learning and algorithms, we are able to have models that allow us to do something or predict something using those models. And the goal of this talk is to bridge both serverless and machine learning, and how we did this in a serverless manner while keeping the cost low. So if you look at the screen, you can see that there are multiple parts of the machine learning process. There's data collection, there's data preparation and cleaning, visualization, feature engineering, up until model deployment. So when you're training your model, of course, use something which is heavily used by a lot of people in terms of the maturity and the performance of the infrastructure. So if you have something like SageMaker to help you automate a lot of those things, SageMaker will help you focus more on the business logic, or at least on what you're doing, to help you work with your model training. So for deployment, there are different options. So the first option is you have a SageMaker endpoint, and you can have a Lambda consume that endpoint, and you use that Lambda along with API gateway or other tools to connect to your, let's say, mobile app, or let's say a web server or something. One other alternative would be to have that model deployment be done inside a Lambda function. So this talk is about having that. And that, I think, is one of the trickier parts of model deployment, because when you use AWS Lambda, you'll encounter a lot of constraints, which are good for developers and engineers, but I'll share the things that we did to help you simplify that process. Details. So Lambda Layers in action. So what's a Lambda Layer? So a couple of years ago, I started out with AWS Lambda, and the thing there was that it's a really simple concept where AWS has successfully implemented that concept, and a lot of people started using it. At some point, when you start doing complex applications, things get trickier, and AWS Lambda Layers was released, I think, last year or something. When it was announced, suddenly all the other languages can be supported inside Lambda because you have the runtime. And then you can have other layers to help you modularize and group the deliverables and deployments and files being loaded inside Lambda together. So there's a module inside Lambda, and you can have 5 of that, And that's what they call a layer. So let's say I have these lines of code. So this is just a scikit-learn example, a simplified example. And I have there where I followed the machine learning process. Um, there's the train test split, there's the model fit, and then predict. When I try to do this locally, it's easy. But once I have to deploy that into production, and let's say that I have scikit-learn inside Lambda, it's kind of tricky to put it inside Lambda. So let's say you have TensorFlow, you have to fit it inside Lambda. You'll encounter constraints, and I'll mention those constraints in a bit. So the goal is for us to solve those constraints and at the same time be able to manage our Lambda layers and our Lambda code properly. So this is how we use R inside Lambda. So R, if you're not familiar with it, so for those who have used it, it's simply another language. And this language is targeting the data scientists and statisticians. And the good thing here is if you're a statistician or a data scientist, you're probably familiar with this one. And the challenge sometimes is when you're a data scientist who's familiar with R, how do you productionalize your scripts? So do you convert that to Python or do you still use R? And sometimes when the tooling is limited or the service does not support the language, it will be harder for you to deploy your R scripts. But in this example, we were able to just transfer our scripts inside the Lambda function, and we were able to make it to work using the AWS Lambda Layers, especially the runtime. So before, we have JavaScript and Python inside Lambda, and we had examples like getting Git to work inside a Lambda function, and it allowed us to do super cool things inside the Lambda function, which we thought before were impossible. And here, we have one layer for R, meaning that any kind of script that we use on top of Lambda works properly, as long as we use the R Lambda layer that supports that runtime. So the Lambda layer is basically just a layer. It helps organize your code. It helps organize your deliverables, because when you try Lambda locally and when you try to deploy it, sometimes you'll find it difficult to upload it inside a Lambda function without getting the experience or without doing some trial and error. So with the Lambda layer, the advantage of this one is if I had to reuse it in other Lambda functions, instead of me trying to copy the deployments in my SAM templates or in my CloudFormation templates or using the framework of my choice, I have the ability to just deploy the layer on its own. Meaning, let's say I have 5 different R Lambda functions, I will be able to have the R runtime available as a layer, and then I get those Lambda functions, use that runtime layer, and I don't need to make it part of that normal process. And I can version it too. So the advantage there is it's immutable and you can version it. And if there's something wrong with that layer, you can just use your previous layer to make things a bit more predictable. And you can have other packages in other layers. So let's say I have pandas, for example. Installing pandas with Python inside a Lambda layer, there are a bit of steps, number of steps before you can get that to work. And the advantage of using Lambda layer there is, if I were to load a package, instead of it being part of the normal process, I will be able to have a package or a layer for it, and then it works right away. I just import pandas as long as I have this layer. So you can technically do this in any kind of language, but when you're dealing with machine learning requirements, the challenge there would be using, how do you use a really big library inside a Lambda function? Because the Lambda function has some constraints like the time limit, I think it's 15 minutes or something. And then there's the package size limit, and then there's the memory limit. So if you're able to work with those constraints, you'll realize that you can make the most out of AWS Lambda and you can reduce your cost significantly. So let's go into a deep dive. So this is going to be part of the last 3 to 5 minutes. So let's talk about the constraints and the challenges. So here's our goal. Our goal is to have scikit-learn inside Lambda. So you have a prediction endpoint using API gateway and Lambda plus scikit-learn. And then you have another prediction endpoint, but this time you're going to replace scikit-learn with TensorFlow. So this one is much bigger. And then you have prediction endpoint and API gateway of AWS Lambda plus Facebook Prophet for forecasting. So this one is also big, meaning it's going to exceed the 250 megabyte limit. So if you were to try to use the normal process with AWS Lambda, you won't necessarily be able to have these two working right away. If you try to use scikit-learn, it's going to work right away. But this one, you need to follow a couple more steps. So the constraint is the total Lambda package size limit is 250 megabytes. And the problem is the TensorFlow or other libraries like Prophet will exceed 300 megabytes if you try to install them inside Lambda. So if you try to do pip install, it's 300 megabytes, and then Lambda will reject it. So the solution here would be to delete files until the total size is less than 250 megabytes. So in this case, for this example, for TensorFlow, let's say you have a model already prepared using SageMaker or other tools, or maybe locally. You get to have that model loaded inside the Lambda. So the model is in S3, but the TensorFlow package is going to be installed first, but you have to delete some files until it gets less than 250 megabytes. So this may look so simple, but you have to do a lot of trial and error before you get this to work. And this is where AWS Lambda Layers come in. Because once you are able to provide the needed files and package and the zip file for it, just with a couple of tweaks, you will be able to convert that into a layer. So let's say you have to use TensorFlow or Facebook Prophet in a different Lambda function. Instead of you going through that iterative process of making it work, just have a layer for it, and you'll be able to reuse that layer without you worrying about getting that mistake again when you try the deployment again. So it makes things simple, and you'll be able to reuse that layer over and over again. And then finally, another technique would be to reduce the binary file size limit using strip. So if you use Python, this is one way. But if you use other languages, make sure you understand the language, the library that you're using, and then repetitively try your process again and check if it works. Because if you delete the wrong file, it will stop working. So if you delete a file which is not being loaded by the library, then you'll get it to work. So why are we doing this again? We have a 250 megabyte limit, and we have to make sure that the total package size is less than 350 megabytes. So what do we do in our company? What we do is we created our own custom container, and what we did there is majority of the optimization steps here are automated inside our container. Because I'm working with a team of at least 10 people focusing on this single machine learning project. And what we did is, instead of me trying to teach them all the one-liner scripts, I just automated a lot of steps, and I just had them use the container, which is basically just a better version, or I just work on top of the container provided by AWS. And I added all the scripts needed to perform this optimization. All right, so basically that's the talk. The goal there is to be able to make the most out of AWS Lambda through the use of AWS Lambda Layers. And in this talk, to summarize, we discussed the different ways to do machine learning inside AWS, but the first one would be SageMaker to train your model. But when you're doing deployment, there are different options. And if you are going to use AWS Lambda, you can make the most out of AWS Lambda Layer and make it part of your deployment process to improve the ability of the team to manage the operational things. And finally, we discussed the constraints like the one mentioned earlier, and we were able to manage those constraints through the use of several optimization steps, like doing strip and being able to remove the files which are not being loaded by the library. And then finally, we optimize and improve our workflow by automating some steps through the use of a container and automated scripts inside that container. So thank you again, and hope you learned something from my talk.